I'll be discussing the problem word break. The problem statement says that given a string S and a dictionary of strings word dict, return true if S can be segmented into space separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. So the word break approach says that every single starting position we are going to check every prefix from the first starting position. If that happens to be a word, then we would start from there. Likewise, we will try every word. How many different words are we gonna end up trying? Let's say n is the size of our string n, and we are going to try basically from every single starting position to the end, so that we will be on big of n into n. And then one more way is possible, where instead of trying every single prefix possible, let's just check every word in our word dictionary. Whatever the word is, just match that word with the input string, and then we will be checking every word in our dictionary as this prefix. The time complexity is b n into m into n. So we will be using decision tree and understand how to cache it to eliminate repeated work and then go to the optimal DP solution using the bottom up approach. So the code explanation says that the solution creates a boolean DP array DP of size len of s plus 1, where DP of I represents whether the substring starting at index I can be segmented. The base case DP of len of s is equal to true means an empty string is always valid. The loop iterates backwards from the end of the string to the beginning, and for each index I, it checks every word in W in the word dict. If S of I, I plus length of W matches the dictionary word, and the remainder of the string dp of I plus length of W is segmentable, then dp of I becomes true. As soon as we find one valid segmentation for a position, we break early for efficiency. And then finally, the answer dp of 0 tells us whether the entire string can be segmented starting from the first character. The time complexity of this solution is 9 into m into k, and space complexity is big of 1. And the pattern which is observed while solving this problem statement is, just a minute, let me search for it. Yeah. Okay, I didn't take out the patterns. Let me just chat GPT what are the kind of patterns which is observed while when we solve similar kind of problem. Okay, so the patterns are one dimensional DP array as the stage storage. DP of I stores whether a subproblem suffix of the string is solvable. Second is Boolean DP over indices, where DP array of true or false instead of numeric counts. Can I or can't I? Third is right to left DP filling, iterating I from length of s of -1 down to 0, so future results are already computed. For this from index I, can I jump to the valid state? Pattern, checking dp of I plus length of W, just like jump segmentation style problems. Fifth is subarray substring checks via slicing. S is I tends to I plus length of W as a pattern of using array string slices inside loops. Sixth is using array as memoization instead of recursion, converting top-down memo into bottom-up DP in a flat array. Seventh is base case at the end of the array, DP of length of S is equal to true as a pattern, where the position after the last index represents an empty valid state. Eighth is early break optimization in loops. As soon as DP of I becomes true, then we need to break in a loop to avoid extra work. Ninth is multiple choices per index, like try all words, pattern of iterating over all options for each index, or ing results. The 10th state depends only on forward positions. Local transition dp of I depends on a small number of later states, dp of I plus length of w, not the whole array.